In this video, I'm going to derive the formula for the derivative of all the trig inverse functions. What does this equal? Okay, well, let's call it y. Y is equal to sine of x. Y is equal to sine inverse of x. Okay, like I said, let's call this y. That means that the sine of x is the sine of y is x. That means that the sine of y is x. Take the derivative of both sides. The cosine of y, the derivative of sine of y is the cosine of y times the derivative of y, and the derivative of the right side is 1. So, y prime is equal to 1 over cosine y. And this is true, but it'll be better if I had y prime not in terms of y, but in terms of x. Well, this here gives me a triangle. And just for the record, the calculus is over. Writing cosine of y using x's is going to come from this diagram. We know that the sine of y, that x is the same as x over 1. We know that the sine of y is the opposite over the hypotenuse, which means that this side must be that squared minus that squared. After all, if you square that, you get 1 minus x squared, plus if you square that, you get x squared, and this is 1. And the square root of one side squared plus the other side squared should be equal to the square root of the hypotenuse, which is 1. Got it. So, with this right triangle, we're done. Cosine of y is adjacent over hypotenuse. It is 1 over the square root of 1 minus x squared. And I can forget this formula all day long. I never have to remember this formula. Why? Because I know how to derive it. It equals to 1 over, was it 1 minus? The square root of 1 minus x squared. And if you must know, I didn't know what this equals. I knew it was going to be 1 over 1 plus x squared, or the square root of 1 minus x squared like we got, or 1 over the square root of x squared minus 1. Knew it'd be one of those. It would be something like that. Now, let us find the derivative of cosine inverse of x. Okay, what does this equal? So let it be y. So y is equal to cosine inverse of x, and my job is to find y prime. But this means that x is the cosine of y. Take the derivative of both sides with respect to x. The derivative of x is 1. The derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle, which is not 1. It's y prime. Solving for y prime, I get y prime is negative 1 over the sine of y. And the calculus is done. I just want to get an expression for sine of y in terms of x. Go to this equation and draw a triangle. And just remember, x is the same as x over 1. The cosine of the angle is y. Okay, the cosine of y is adjacent over hypotenuse. Just like before, this must be 1 minus x squared. Okay, so what is the sine of y? Well, it's the opposite over the hypotenuse. It is the square root of 1 minus x squared. Meaning that the difference between the two proofs we just did is they're the same except for a sign. Okay, so now, what if I have y is equal to the tan inverse of x. What is the derivative? Well, I can take the derivative of y and get y prime, but I don't know how to take the derivative of tan inverse of x. After all, that's what I'm trying to derive. So somehow we need to get out of it, and just like before, we say x is equal to the tangent of y. I take the derivative of x with respect to x. I take the derivative of tan y with respect to y. The tangent of any angle, the derivative of the tangent of any angle is the secant squared of that angle times the derivative of the angle. So y prime is 1 over secant squared y. And secant squared in the bottom is the same as cosine squared y in the top. Let's see if I'm going to write it that way or not. So we go to this equation. It's a trig. It's giving us trigonometric information about the angle y. Here is y. The tangent of y is x over 1. So it's opposite over adjacent. That means this must be this squared, which is 1, plus that squared. Okay? Now, we want the cosine. Well, the cosine of y is 1 divided by 1 squared. Okay, the cosine of y is, it's 1. I'll just write it. This is the cosine of y, but we want to square it. So y prime is equal to 1 squared, which is 1, divided by the square root of 1 plus x squared, which is 1 plus x squared. This is the derivative of the tan inverse of an angle. I know, we just proved it. And I think the only one I knew was this one. That is, I knew that the derivative of arctangent of x is 1 over 1 plus x squared. I don't work with these anymore, so I don't remember them. This one I happen to remember. But the other two I didn't remember. But anytime I need it, I have it. And this video was maybe 4 minutes long, and I did 3 proofs, and I actually talked a little bit. It's not that long to derive it. Okay, see you in the next video. Leave some comments about what you thought about this, if you know a different way of doing it, and of course if you like for me to do a proof.